Welcome all in my lecture Swiss PDB Viewer. The Swiss PDB Viewer, also known as Deep View, is a software tool used for the visualization and analysis of three-dimensional protein structures. It was developed by Nicholas Guess and Manuel C. Prats at the Glaxo Wellcome Research Laboratories in Geneva, Switzerland. This software is particularly useful for researchers and scientists working in the field of structural biology and bioinformatics. Key features of Swiss PDB Viewer include: first, protein structure visualization. It allows you to visualize protein structures in 3D. You can load protein structure files in various formats including PDB, protein data bank files, and explore them in detail. Second, structure manipulation. The software provides tools for manipulating protein structures such as rotating, translating, and zooming in on specific parts of the structure. Third is structure analysis. You can perform various structural analysis including calculations of molecular surfaces, electrostatic potentials, and hydrogen bond networks. Fourth is modeling. It offers features for building and editing protein structures, making it useful for tasks like homology, modeling, and docking studies. Fifth is sequence structure alignment. You can align protein sequences with their corresponding 3D structures to better understand the relationship between sequence and structure. Sixth is molecular dynamics. It supports molecular dynamics simulations, allowing you to study protein dynamics over time. Seventh is scripting. The Swiss PDB Viewer has a scripting interface that allows you to automate tasks and create custom scripts for more advanced analysis. Eighth is integration with Swiss model. It integrates with the Swiss model servers, which is a widely used resource for protein structure modeling. The Swiss PDB Viewer is a valuable tool for researchers in structural biology, biochemistry, and related fields. It helps them gain insight into the structures and functions of proteins, which are fundamental components of living organisms. Researchers can use it for tasks such as studying protein ligand interactions, investigating protein folding, and designing new drugs. Please note that my knowledge is based on information available up to September 2021, and there may have been updates or changes to the software since that time. You can visit the official Swiss PDB Viewer website or relevant academic sources for the most up to date information and software downloads. The Swiss PDB Viewer has played a significant role in advancing structural biology and has been instrumental in the analysis and understanding of protein structures. Researchers continue to rely on it for a wide range of applications, from drug discovery to the study of protein ligand interaction and protein folding. Now, we will discuss on the features of the deep view of the new Deep View Swiss PDB Viewer version 4.0. Before we start explaining the software working options, first download the software from the home page of the Swiss PDB Viewer. Deep Viewer. This is the home page of the Swiss PDB Viewer or Deep View. Link the open. The home page is https://spdbv.unil.ch/. This is the home page of Swiss PDB Viewer. From the left side of the menu, click on the download tab as shown in the home page in the red circle. The download page open as shown. Click on the link at the bottom of the page circled in red color. Another page appeared as shown. This is the final page from where you can download the software Swiss PDB Viewer. You can download the software as per the configuration and operating software installed in your computer system. MS Windows existing in your PC. Therefore, we click on the Microsoft window link shown in this page. After clicking on this link, your software starts downloading in zipper folder. Copy this folder and keep it in the specific position in your PC. Open the zipper folder and double click on the application file spdbv. Your software will open as shown on the screen. We will start learning about deep view by looking at the enzyme lysozyme in complex with the trisaccharide inhibitor tri and acetylglucosamine or TriNAC. See a biochemistry text in your want to know more about lysozyme. Atomic coordinates for this model are contained in the protein data bank file with code 1HEW. You can also obtain 1HEW file from the protein data bank using your web browser by following the instructions. First, open a new window for the PDB homepage. Second, slide the PDB window aside so that you can read these instructions and carry them out in the PDB window. Third, a search box with a site search button in near the top of the screen in the middle. Make sure that PDB ID or keyword is turned on. Button to left of box and type 1HEW. The first character is the number 1 in the box. Then click the site search button. The structure page for 1HEW appears. Fourth, your browser should download the file by clicking on download file tab. It asks for formats. Click on the PDB format. The PDB file start downloading as shown. Your software deep view is already open. Click on the open dialog and find your downloaded file 1HEW. Select it and click the open button. You have already learned about the protein data bank. You should now be looking at red, white and blue wire frame model on a black background. See if you can spot the inhibitor, which is composed of 3 chair form rings on N acetyl glucose. It's not easy. Coming section of the tutorial will show you how to highlight or single out specific features of a model and make them jump right out. Before moving forward, we shall make a couple of settings that streamline initial program operation. On the menu bar of Swiss PDB Viewer, click on the Preferences drop down menu bar and click on the General option. A dialog box open. Make few changes in settings. Unlock show splash screen at startup. Uncheck show log file upon loading. Click OK. On startup, Deep View opens two windows. The display or graphics window, which is labeled with the name of the PDB file and the window size in pixels, and the control panel on the right. If the control panel does not appear, use the command wind : control panel to display it. The control panel lists the amino acids, residues and the other contents of the PDB file. You use the control panel to select residues, establish the content of the display, label residues and color them. Above the graphics window is the toolbar. You use the graphics window and the buttons on the toolbar to view, manipulate and measure the model. You must click on a window to make it active. The first click on an inactive window activates it, but does not cause other changes. Other windows are available. You will now display them. The Range menu allows you to open any of the deep view windows, including the windows already mentioned. Now click on Range tab in the menu bar and select the option Sequences Alignment. The narrow align window appears below the graphics window, showing the amino acid sequence of the protein in one letter abbreviations. You use this window when comparing sequences of two or more proteins. Now click on the Select tab in the menu bar and select all options. The color of residues listed in the control panel changes from black to red, and in the sequences alignment window from white to purple. The new color means that a residue is currently selected. Some deep view commands affect only the selected residues as shown. Click on the Vine tab in the menu bar and select the option Ramachandran plot. The Ramachandran plot window appears in the upper left. You can use this window to judge the quality of a model by finding residues whose conformational angles lie outside allowed ranges. You can also display and change conformational angles in the module. Each dot actually a tiny cross or square on the diagram gives the phi and psi angles of one residue in the protein. Because all residues are selected, all are represented in the window. This is Ramachandran plot on the screen. Now click on the Vine tab in the menu bar and select the option layer infos. The small layer infos table appears at the upper right. This table provides control of multiple proteins models, allowing you to choose which models are visible, which models can move and which models have certain features on display. Each window displays a small red question mark. Click the question mark for help in using the particular window. On the toolbar below the first square button on the left, zoom and center, are two symbols, a globe and a little dog-eared piece of paper, document icon. Click the document icon to see the PDB file of the protein currently on display. This file will come to mean more to you later. Close the file window before proceeding. For now, close the Align, Ramachandran plot and Layer Infos windows. Click on the graphics window to make it active. Notice the row of buttons in the toolbar above the window. Click the first one on the left. This is the zoom or center button. It automatically zooms to fill the screen with whatever is currently on display. Click on the Wing tab in the menu bar and select the option Preferred tab. Deep View shows you the current attributes of the graphics window. Notice the features of the display that you can adjust with this window. One is the window size measured in screen pixels, which gives you a precise way to set window size when making an image for printing, but there is an easier way to arrive at a convenient size for the graphics window, especially for arranging it among the other windows. Click cancel on this dialog and then move the cursor, which at the moment has a curved arrow on it, to the bottom right corner of the graphics window. When you are in the right position, the cursor changes to an arrow standard pointer. Now you can click and drag the lower right corner of the window to change its size. Adjust the size to suit you. Do not hide the control panel and leave at least an inch at the bottom of the graphics window for later use of the align window. The next three buttons on the toolbar control movement of the model from left to right. They translate, zoom and rotate. Try each one. First, left click to activate the button, then left click drag the mouse left and right to see the effects. Notice that the cursor changes to show you which button is selected. Watch the cursor as you press the tab key repeatedly. Pressing tab cycles through the three movement functions from left to right. Now hold down the shift key while pressing tab repeatedly. This action cycles through the movement functions from right to left. If you keep your left hand at the keyboard while using the mouse, you can select any movement function in a single option without having to point and click on the buttons. Shifting among the three movement functions is even easier if you have a two button mouse. Left click drag gives you rotation, right click drag gives translation and left plus right click drag gives zoom. In whatever way to zoom, you will find it more natural to zoom in by moving the mouse towards you and zoom out by moving it away. It's as if you pull the model toward you or push it away with the mouse. Because deep view displays only in wireframe without depth queuing, stereo viewing will help you to carry out mouse functions precisely. Here's some instruction in stereo viewing. Click on the tab display and select the option stereo view. Deep view display a stereo pair shown on the screen. Zoom or center using zoom or center button or the appropriate key for your computer. You may need to adjust stereo settings further in order to achieve comfortable viewing. Click on the tab prefs and select the option stereo display. A dialog box appears. Use this dialog to set stereo view, rotation and separation. Try setting a rotation of 4 degrees, that's -4 a cross-eyed viewing. See stereo viewing. Decrease the separation if the views are too far apart to fit the windows or for comfort. For cross-eye viewing, I use a separation of 180 pixels on a 17-inch laptop with 1140 into 900 screen. Each time you change the separation, close the dialog and zoom or center the model and see how well it fits the window. You use the control panel to select, display or hide parts of the model. In the deep view user guide, see link in contents, parts of the model are called groups, meaning amino acid residues or heterogroups like the 3 NAG residues in the lysozyme inhibitor that is bound to lysozyme in PDB file 1HEW. Selecting groups does not change the display, but most actions that you take on the model affect only the currently selected groups. The control panel lists all the groups in the model and gives you fast and powerful means to select, hide and display. You may find this panel imposing at first, but when you get the hang of it, you will be able to control the display and determine the targets of commands very quickly and precisely. Take time to play with the panel and watch its effects on the display. Click anywhere on the control panel window to make it active. The first click on any window activates it, but does not change any of its settings. First, simply scroll down to the button of the list to see how many amino acid residues the protein contains and to see how the stereo groups are named at the bottom of the list. Hetero groups are always listed last. The TriNAG inhibitor is listed as 3 residues of a NAG number 201 to 203. Now click and drag starting on the word GLY4 at the top of the window, dragging down to GLY16 and releasing the mouse button. All group names from GLY4 through GLY16 should turn red. Groups printed in the red are now selected. The simplest way to select a small number of residues is to click their names and drag to select a range of them. Click the check in the side column next to MET12 to hide the side chain. Click the same space again to replace the check and display the MET12 side chain. Try the same thing in the show label and surface little circle of the dots column and look at the effects. Surface display are dotted when their wall surface for the group. Remove the checks from the label and surface columns. Again select and display residues 4 to 16 with side chains. Control panel heading. Label meaning, click the small word label at top of the label column in the control panel. Clicking the word label at the top of the control panel labels all selected residues. Heading. Surface. The surface symbol is a little cluster of dots. Clocking. The surface symbol shows a dotted surface on all selected residues. Heading. Ribbon. Clicking the word ribbon draws a smooth standard cartoon of the selected backbone. In general, clicking a word, a heading at the top of a column in the control panel adds the corresponding display for selected red residues only. Rotate the model and you will see that SPDBV sometimes simplifies the display during rotation in order to make rotation faster. In this case, Deep View removes surface displays and residues ribbon to one standard during movements. Remove the labels, surface and ribbon as follows. Hold down the shift key and click any check marks in the label column, not the word label. Repeat for the surface and ribbon column. When you click on a check mark while holding down shift, your action removes all check marks and Deep View makes the corresponding changes in the display. On the other hand, when you shift click an empty space, Deep View places check marks in that column beside all groups and takes the appropriate action. Try this out by shift clicking several times in the Show column. This displays and hides the whole model with all groups shown. Shift click several times in the Side column to display and hide side chains, and with side chains hidden. Shift click in the Ribbon column to display and hide a ribbon cartoon for the whole model. Remember that you can center the display at any time with the zoom or center command. Next, select and show residues 4 to 16 with their side chains and add residues 17 through 22 as follows. Click in the Show column next to LEU 17. Drag down the column to GLY 22 and release the mouse button. Arrows should appear in the Show column next to residues 17 through 22, but these residue names should not turn red. If you drag too far, release the mouse button and then remove unwanted check marks by clicking them one at a time. Add check marks in the Side column for residues 17 to 22 in the same way. Now residues 4 through 16 are selected and shown, while residues 17 through 22 are shown but not selected. The menu command selects all groups, Return displays them, and clicking the side heading adds the side chains. Tools: compute H bonds in the blink of an eye. Deep View finds and display all potential hydrogen bonds in the molecule, including those involving side chains and hetero groups. Deep View displays hydrogen bonds as green dashed line. You will learn more about this feature later. Select secondary structure, helix, return. You should see only the alpha helical regions of lysozyme with hydrogen bonds shown. Turn off all side chains. Look around to confirm that the segments shown are helical. Confirm that most of the hydrogen bonds are from the carbonyl oxygen of residue N to the amide nitrogen of residue N plus 4. Notice the control panel. Only the residues in helix are red. This allows you to take further action on the selected groups, such as coloring them, as you will see in the next section. Select secondary structure, strands, return. You should see only strands of beta plated sheet. Notice the characteristic pattern of hydrogen bonds in the strands, which strands are parallel and which are anti-parallel to each other. Illustrate this by drawing an arrow diagram of the sheet. Display. So, H bonds, you will find that this command has a check mark to its left, which means it is turned on. By selecting it, you turn it off and remove the hydrogen bonds from the display. Notice the other select menu commands. Can you select and display only the residues whose side chains carry positive charge, so called basic residues? Can you select and display only the histidine residues and their side chains? Look at the sub menu that pops up when you choose select group kind. How many histidines are present in lysozyme? Wind, layer in force. The layer enforced window provides information about the display. Note the cell heading at the top of the far right column. This column shows the number of groups currently selected. Again, select the basic residues and notice the number selected under the cell heading. Now select acidic residues. Compare the number of acidic and basic residues in lysozyme. Would you expect the isoelectric pH or pI of lysozyme to be above or below pH 7? It is around pH 10 because basic side chains outnumber acidic ones. Put away the layer enforced window by clicking on its close box, the small square in its upper left corner. Select only groups NAG 201 to 203 and then press return and help. You should see try NAG only. Manipulate and get to know this triacetyl structure. Another powerful selection tool lies at the top of the graphics window. It is the 9th button from the left, showing an eye and a circle. Click this button. In the message space just beneath the moment icons, Deep View instructs you to pick up an atom. Click the nitrogen atom, blue, on the center ring NAG 202. A dialog appears. Click to darken the first button, add to display, type the number 8 in the box and click OK. You have added to the display all groups having at least one atom within 8.0 angstroms of the atom you picked. You may need to click the side heading in the control panel to add the side chains. This is a nice feature for focusing your attention on specific atoms and their neighbors. Notice that Deep View adds these groups to the display but does not select them. Other buttons in the dialog allow you to select the neighbors or to display only the neighbors. In addition, select visible groups allow you to change the current selection to include all groups on the screen. More commonly, you might want to display all groups within a specified distance of the selected groups. Accomplish this selection as follows. First, select and display only NAG 201 to 203. Select neighbors of selected amino acid. In the dialog, type the number 4.5 in the box and click OK. You have added to display all groups having at least one atom within 4.5 angstrom of any atom in NAG 201 to 203. Here is yet another powerful means of selection. Select display and center the whole model with side chains. Display. So, edge bonds, you computed edge bonds earlier and Deep View still remembers them. Now, select NAG 201 to 203, select only, do not remove other groups from the display. Display, show only edge bonds from selection. Display, show only groups with visible edge bonds. Help. With this simple set of commands, you have limited the display to the tried NAG inhibitor and residues to which it is hydrogen bonded. Select visible groups, select invert selection, heading, ribbon, then help. Now, you should have a model of lysozyme in which tri-NAG and its hydrogen bonded groups are shown in wireframe with all the rest of the model shown as a ribbon. The command select inverse selection is a handy way to select only the groups not currently selected. Anytime you want to carry out an operation on everything except the current selection. Remember this command. Turn off the ribbon by shift clicking any check mark in the ribbon column. Now click anywhere in the empty chain column, left column of control panel, and press is less than, return is greater than, and is less than, half is greater than. The whole model reappears because there is only one chain in this model. A click in the empty chain column selects the full model. For further viewing the structure, download the tutorial from the home page of the Swiss PDB viewer as shown in this figure. Thanks for listening. Thank you.